Alright, the video's recording. So, hi everyone, I'm Pearson. I graduated from here in 2010, and I'm now a physics student at Curtin. So I'm somewhere in between my second and third year. So yeah, Mr. Collins has asked me to come in to teach you guys about waves, and I'll be taking it all the way through till we finish quantum mechanics, because he thought it would be better if you guys learn it from a student's point of view. So yeah. So I guess we'll begin. Okay, there's three types of waves that we've encountered in everyday life. Can anyone read that?
Yeah.
Of course they can. They can read my writing. Really easy.
So there's three types of waves. We classify them as mechanical, electromagnetic, and matter. So no pun intended, but you guys have all heard of sound waves, right? So everyone's probably more familiar with mechanical waves. The second one, maybe we're not so familiar, but we see it every day. We see light as an electromagnetic wave. And the last, probably no one's heard of, is a matter wave, which and we'll go through all three of them by the end of my section in this course. So let's focus on mechanical waves first. Now, the thing about mechanical waves is that they require a medium to transfer, to go through. And there's two ways a mechanical wave can move. One is one's a transverse wave and one's a longitudinal wave. So this lesson is mostly just explaining what these two are and just giving an introduction to waves. A transverse wave, when it moves, it goes like that. How many of you have seen that? Like this shape. Like when you throw a pebble into like a river or something, it forms this shape, right? And a longitudinal wave, when I speak, do you think the sound wave comes out of my mouth like that? Anyone?
Yeah.
No.
Yeah.
Round, maybe?
When you speak, do you feel the pressure going to the top of your fingers, or right in front, or right smack in the front of where the sound's coming out from?
In front.
Say the letter A.
Hey.
So does it come out right smack in front, or does it go up a little bit?
Try
Try going.
That's a better one. So if you aim at the palm of your hand, does it hit the top of your fingers or your palm?
Palm. I can't feel it.
Okay, in actual fact, it just goes straight.
They could spend hours doing it.
Yeah, I should have left it for a little bit more. That's what we call a longitudinal wave. When you speak, the air pressure in your mouth pushes the molecules right in front of your mouth. So the air pressure coming from my mouth pushes the air molecules right in front of my mouth, and it goes like that. And this molecule moves back, while this molecule moves front, and it kind of oscillates, and that's why it goes straight. So it's all very abstract right now because I'm just kind of pulling words out of my mouth. So we kind of had a little demo with a nice little slinky to kind of explain the concept. So could everyone gather around so just not block the camera?
I don't want to send it.
You need a real view of this. You probably want to move your book.
Trying to avoid the camera.
We good? Alright.
It's kind of
So everyone knows what a transverse wave is, right? So it propagates, it moves by going up and down. The displacement of the air molecules are perpendicular to the wave, to the direction of which the wave is traveling. Along the longitudinal wave, as I was saying, is kind of like the pushing and reversing of the air molecules in front of your mouth. It moves like this. Can everyone see like a little pulse that goes through?
Yeah. Cool.
No.
Yes, it is. It's very
I
good.
won.
That's what that's what a longitudinal wave is.
Again.
I want that
How many more do we need?
Transverse again.
one. Big one.
Big fan.
So when a longitudinal wave travels, I'm going to use the word propagate from now on to refer to a wave traveling, alright? When a longitudinal wave propagates, it kind of, as you see the pulse travel along the slinky, that area in the pulse would have higher pressure. Would you agree? So when I'm speaking, the reason why you can hear the sound coming to you is because there's high pressure in the air molecules coming to you. So the terms that we use for a longitudinal wave propagating is what's it? Rarefaction and
Rarefaction and compression.
there we go. We use it as compression and rarefaction. When we say compression, we mean the part where the molecules are coming together, and rarefaction is when the molecules are pulling apart. So a longitudinal wave is kind of like moving like that. So now that we've kind of talked about the two types of waves as they move, can anyone tell me one similarity that these two motions have in common?
They move in a direction.
Yeah, go on.
They move in a direction. Anybody else got something?
Waves.
Light.
They're waves, yes.
Is it the net displacement of the molecules is like 0?
Yeah. A wave is just a transfer of energy without all the molecules in between moving. Or at least they oscillate but they come back to the same position. So that's what a wave is, and that actually is a key concept when you guys go towards quantum mechanics. And
Yeah.
has anyone ever seen a pictorial representation of a sound wave? It's on page 189 of your textbook if you don't have it.